probability today, 7th graders. Your learning target, you can calculate experimental and theoretical probabilities. That's what we can do. You've been exposed to this plenty of times. Well, maybe just last year. I don't really know how many times you've been exposed. I definitely know it's a 6th grade standard, so I know for a fact you were exposed to it last year. Experimental probability states the probability of an event happening, you call it like that, you put it like this, P parentheses event. That means probability of an event is equal to the number of times an event occurred over the total number of tries. That's experimental. Experimental, think of the root word experiment. That means you are actively doing something. Theoretical probability states the probability of an event, P parentheses event, it means probability of an event, is equal to the number of times you would expect, theory, okay, expect an event to happen over the total possibilities. So you really look at the root words there. Experimental, you're actively doing something. You're actively doing an experiment. Theoretical, it's in theory you should get, what? If you were to toss a coin, in theory you should get 1 heads each for 2 flips, okay? So experimental, you are doing something. Experimental, you're doing something. You could now, tossing a coin can be experimental or theoretical. It all depends. But doing something like tossing a coin, drawing a card, again, that's one that could be theoretical too. Drawing, like picking a card, drawing a card. Another experimental would be batting average. Batting average is a probability, but it's just stated as a decimal. But it's an experimental number of times at bat over, or no, it's number of hits over times at bat. It's an experimental probability situation. Theoretical is analyzing, predicting. Okay, same situation. You're saying, well, you should get this. Okay, so theoretical could be a coin toss. It could be drawing a card. What's another theoretical?
Rolling a dice.
Yep, rolling a die. Yep.
Would be like
A spinner.
yeah.
Yeah.
Stock market directions.
Stock market. They do a lot of theoretical, and it could be experimental too. Stocks. But they do a lot of theoretical. In theory, this is what should happen. 3 ways to express probability. What do you think are the 3 ways? Think pair share.
One of them?
Yeah.
Fraction.
Fraction is a way to express probability. Absolutely. The probability of an event is equal to some kind of fraction. Eric?
Decimal.
Decimal is another way. And this, I like that you said decimal first because this is the beautiful sequence that I would expect everybody to do. So the probability of an event is equal to point something, whatever you have, percent. And that's the order I would go. That's the logical order. I always start with fraction first, turn it to a decimal, top divided by bottom, and then turn it to a percent. That's always what I do. So the probability of some kind of event is equal to some kind of percentage. Okay? Okay, given the table of tossing a coin, what's the probability of getting heads? Now I want you to tell me, is this an experimental or theoretical probability?
Experimental.
This would be an experimental because I'm looking at a chart where somebody actively tallied something. So the probability, you write it like this. The probability of getting a heads is, I always start with a fraction. 8 out of how many total tosses did they have? 5, 10, 15, 20. You do not leave it like that. You simplify probabilities. So this would be for what? 2/5. And then I'm just going to have you all, get used to transferring, my goodness, into all forms. So the probability 2/5 is 0.4, which is 40%. You always want to be able to go fraction, decimal percent, fraction, decimal percent, always. Okay, the scientist Gregor Mendel crossbred green seed plants and yellow seed plants. Out of 8,023 crosses, 6,022 plants had yellow seeds and 2,001 had green. Find the probability that a plant had green. Now, is this experimental or theoretical?
Experiment.
He actively documented something. Now, what about when you guys just had your unit in science on Punnett squares? Is that theoretical or experimental probability?
Theoretical.
Those are theoretical. Theoretical, because you're making assumptions.
If you look back at it, it would be,
If you actively looked back at each one, then it would be experimental.
yeah, but that was
Okay, yep. Okay. So let's see, we want to find the probability that a plant had green. So I say probability of green is equal, so I had 2,001 green seeds over 8,023 total crosses. Now I don't like these numbers at all. Do you like these numbers?
No.
too big.
They're too big, so I just leave it there. Go fraction, decimal. So top divided by bottom, 2001 divided by 8023 is rounded to 0.25. Rounded, it's not 1/4. Rounded to 0.25, which is 25%. Approximately. Okay, next. Identifying types. Now we've been doing this ever since I started the lesson. Looking at this table, pretty much anytime I see a table, right away my brain says, hey, people tallied, people actively did something. That tells me it's an experiment. But it says probability favor. So they surveyed town voters. The number of people surveyed is 200. People in favor of some kind of thing is 110. Probability of voting in favor is 55%. Is that an experimental or is it theoretical?
Theoretical.
Experimental.
Experimental, yeah.
It's experimental.
I meant to say it, but
It's experimental because somebody was surveyed. You're experimenting. You're asking people. You're not making guesses. Okay? Just like if we surveyed people here about Science Fair History Day, thinking that we're a STEM school, we'd say the probability of students enjoying history and science fair would be 80+%. Well, and if we actually did an experimental survey, I'd have a funny feeling it wouldn't quite be that high, right? But I tell you, your projects look beautiful.
Okay.
Okay, a bag contains 2 red and 3 white. Does the probability of red equal 2/5 represent experimental or theoretical probability? Theoretical, because I didn't draw anything. I'm just saying here's a bag and I have 2 red cubes and I have 3 white. Pretend these are white. And the probability of getting red, well, there's 2 red out of
3.
out of 5 total. So I didn't actively draw. I didn't tally anything. I didn't create a table. I didn't experiment at all. Yep.
Could you always also tell what it's asking you asking you a question that tells you?
Right. Dependent, because they ask you a question here. They might say, what's the probability of people in favor of it? But that's an experimental. Okay, odds. This is the ratio. This is talking about like lottery winnings, things like that. The odds in favor. You do the number of favorable to the number of unfavorable. That means what you want to what you don't want. What you want to what you don't want. Odds against. Number of unfavorable, what you're not looking for, to number of favorable. So you just flip it. What you don't want to what you want. It's the same, so it's actually a fourth way to represent probability. Because a ratio is really a quotient written in a horizontal fashion. So given the balls on the left, what are the odds of selecting a yellow? Okay, what are the odds of selecting a yellow? So odds are slightly different. So it's what do I want? I want yellow. So want to don't want. Okay, so I want yellow. I don't want, what is that, orange? Orange or red or, bear with my old eyes, okay?
Other colors.
So I want yellow, there's 2 yellow. I don't want the orange, which there are 1, 2, 3, 4, 5. When you add odds up, you should get your total amount. Okay? What are the odds against selecting a yellow? So what we're really doing here is not yellow to yellow. And you just flip it. 5, not yellow, to 2 yellow. Okay? Okay, the next thing we're going to talk about is complement of an event. It's the probability of an event not occurring. This should be an event not occurring. Complement of an event is the probability of it not occurring. So the ways you can find it, you can find the probability of not. Okay? What I mean by that is if I wanted to know the complement of the probability of heads, I would look for the probability of tails. Okay? So you're looking for that opposite. Or, this is the best way to do it. You do 1 minus the probability of the event. Why you can do that is probability is really if you add the probability of it not happening, okay, to the probability of it happening, the probability of it not happening plus the probability of something happening is always going to equal 1. So the probability that it's going to snow tomorrow and the probability that it's not going to snow tomorrow, it's either going to snow or not snow. If you added them up, it's going to equal 1, which is 1.0, which is 100%. Okay, so probabilities always add up to 1. Okay, probabilities always add up to 1. So the probability finding complements is just looking for everything but it. Suppose you pick a card at random. What is the probability that it will not be a face card? Okay, I like to do the probability that it is a face card. Okay, because it's smaller numbers. So probability of face card, there's 3 face cards, right? Jack, Queen, King. We're not counting aces as a face card. 4 suits. So it's 12 out of 52 cards, which is, divide them by 4, 3/13. That's a probability that it is a face